Hi everyone! I'm very excited to announce that you are watching your first flip video of the school year. Make sure you keep in mind everything we talked about in class while watching the video. So the first thing we're going to go over is what it means to square a number. So squaring a number means to multiply a number by itself. So I have listed the first 10 squares up at the top, so make sure you write these on your paper. So 1 times 1 equals 1, or 1 squared equals 1. 2 times 2 equals 4, 2 squared equals 4. 3 times 3 equals 9, 4 times 4 equals 16, 5 times 5 equals 25, 6 times 6 equals 36, 7 times 7 equals 49, 8 times 8 equals 64, 9 times 9 equals 81, 10 times 10 equals 100. So make sure you have these at the top of your paper. You'll be required to know at least the first 10 perfect squares. So make sure you have these listed at the top of your paper. Alright, the next thing we're going to go over is what it means when we take the square root of a number. So when we square root a number, we're looking for the value when multiplied by itself gives us that number. And as we practice some of these, you'll understand more what that means. Alright, the next thing we're going to go over are perfect squares. So the easiest square root problems are from perfect squares. These numbers have two identical integer factors. And if you recall what it means to be an integer, we mean whole numbers and their opposites. So when we take the square root of a number, there will be a positive and negative answer, since integers are positive and negative numbers. And we like working with perfect squares because we get an integer as the answer. So we don't have to work with decimals and fractions. We can work with whole numbers, and it makes it a lot easier. Alright, so let's go over some examples. Example number 1, we're working with the number 25. So we're looking to take the square root of 25. So as we look at the top, we can look at some of the numbers we've listed already. And if we look up here, 5 squared, or 5 times 5, equals 25. So we can write 5 times 5 equals 25, which also means it's the same thing as saying 5 squared equals 25. So when we take the square root of 25, our answer is 5. And just as we mentioned right up here, perfect squares have two identical integer factors, whole numbers and their opposites. So here we listed the positive root, but the square root of 25 is also negative 5 as well. Because if we think about it, 5 times 5 equals 25, and negative 5 times negative 5 also gives us a positive 25. So when we take the square root of a number, of a positive number, it has two roots, the positive and negative root. And the reason they're called perfect squares is because if we think of an actual square and the area being 25, we could think of the side lengths being 5. So 5 times 5 equals 25. And for these real life problems, like working with the square, we usually just use the positive roots because we can't really think of a side length being a negative number. That doesn't make sense. So for those problems, if it says if the area is 25 and what would the side length be, you can just list the positive root because it doesn't make sense to use a negative number. Alright, so looking at example 2, 81, we're trying to think of a number when multiplied by itself will give us 81. And if you look at the top, we have it listed. So 9 times 9 equals 81, or 9 squared equals 81. And just as we just said, we can also think of negative 9 times negative 9 gives us 81. So negative 9 squared is also 81. And thinking of the square root of 81 is 9 or negative 9. And just as the last problem, we could think of the area being 81 and the side lengths being 9.
Alright, so now we're going to go over some more examples. So we're going to identify the square roots of the following perfect squares. Alright, so the square roots of 16. So if we remember our definition of a square root, we're trying to find a number 1 multiplied by itself that will give us 16, or give us that number. So what number 1 multiplied by itself will give us 16? So the answer to that, the integers are 4 and negative 4. Because 4 squared and negative 4 squared both equal 16. Alright, for number 2, the square roots of 49. So we're finding the square roots of 49. So what number, when multiplied by itself, will give us 49? What numbers? Alright, so those numbers are 7 and negative 7, because 7 squared and negative 7 squared both equal 49. Alright, so on to numbers 3 and 4. So I want you to try these on your own. We've gone over a couple examples now, so I want you to pause the video and try numbers 3 and 4 on your own. Okay, it's okay if you get them wrong. Hopefully you're using a pencil so you can erase them, but pause the video and try them on your own and then replay the video to see if you got them right. Okay, so let's see how you did. So for number 3, the square roots of 4 are 2 and negative 2, because 2 squared and negative 2 squared both equal 4. Okay, so if you got that one right, great job. If not, it's okay, we're still practicing. Okay, and for number 4, the square roots of 169. This one was a pretty hard one. That one's pretty up there. The square roots of 169 are 13 and negative 13, because 13 squared and negative 13 squared equal 169. Okay, so when we find the square root, we're just looking for a number when multiplied by itself will give us that number.
Finding square root on a calculator. When you find the square root on the calculator, only the positive square root appears. This is called the principal square root of a number. So when you find the square root of a number, usually the first thing you think of is the positive square root, but you need to remember there's both a positive and negative root. So when you find it on your calculator, it's only giving you the principal square root or the positive square root. So if the problem is asking for the negative square root, then it will look like this, with the negative out in front. Then it's asking for the negative square root. So the negative square root of 4 would be negative 2. If the number is asking for both the positive and the negative square root, it will look like this. So having both the positive and the negative out in front is showing that it's asking for both the positive and the negative square root. So that's 2 or negative 2. Alright, so for these examples, try them on your own first and then play the video to see if you're right. So for number 1, this shows us we're looking for the negative square root of 100. We know that's negative 10. Just to check, we can do negative 10 times negative 10 equals 100. For number 2, we're looking for the negative square root of 64. And that would be negative 8. Negative 8 times negative 8 equals 64. And for these examples, we can see we're looking for both the positive and the negative roots. So the square root of 49 is 7 or negative 7. And positive and negative square root of 9 is positive 3 or negative 3. So negative numbers have no real square roots. Why? Well, when we have the notation like this, we're looking for the negative root of positive 4. But so if we're saying negative numbers have a square root, we'd say that we can find the square root of negative 4. So if you think of that, you automatically think maybe we're talking about 2, but as you can see, we do positive 2 squared, we get 4, and if we do negative 2 squared, we get positive 4. So there's nothing we can multiply by itself that will give us a negative 4. So they have no square roots. And we can think of this for any number. There's no way we can multiply anything by itself to get this negative. So that is not true. Now these are your video questions for today. So for number 1, if 6 is the answer, what is the square root? So for number 1, you're answering that question. And for number 2, true or false, 16 is a perfect square number. So you're answering these questions in the Google form, so I know you watched the video and you have a good understanding.